Hello students, once again welcome to all of you students of applied mathematics. Today we are going to discuss about logarithm. Our next chapter, or we can say next topic also, logarithm. Now the main point is, what is logarithm? Simply we can say it is the reciprocal of indices. As like you know, we can write 2 cube equals to 8. That means 3 times of multiplication of 2 gives us the result 8. In the same way, logarithm is just reciprocal of the indices. As we know, this is the formula, or this is the rules of indices or notation of indices. And in the way of logarithm, this is expressed as log 8 with base 2 equals to 3. That time when base is known and result is known but component is unknown, that time we use logarithm. So we can say logarithm is just reciprocal of indices. I am giving another example. Suppose 2 to the power 5 equals to 32. It means 5 times of multiplication of 2, that gives us the result 32. So logarithm of 32 with base 2 equals to 5. Okay, or we can say 2 to the power 5 equals to 32. Suppose log x with base a equals to b. What we can write from here? If we can write from here 2 cube equals to 8 implies logarithm 8 with base 2 equals to 3. So hence we can write, see, 2 cube. See, this is a cross multiplication, but these 3 will be in the power or components. So in the same way, a to the power b equals to, you can say, x. This is the main, or you can say, definition of logarithm. This is the main law of logarithm, or you can say this is the definition of logarithm. Unless obviously a not equals to 0. Unless obviously a not equals to 0. So what is our conclusion? When result is known and also base is known but component is unknown, that time we use logarithm. In case of indices, base is known and component is known, we have to find the result. But in case of logarithm, result is known, base is known, but component is unknown. That time we use logarithm. Okay. Once again I repeat, suppose what is the value of 2 cube? Simply we can say 3 times of 2, that gives us 8. That is the components. But when result is known, but base is also known, but what is the power? That time we use the logarithm formula. That time we write as logarithm 8 with base 2, and this gives us 3. Or we can say 2 to the power 3 equals to 8. Okay, that is the main or law or the definition of logarithm. Now we are discussing about the laws of logarithm. First of all, number 1, what is logarithm x with base a equals to b implies a to the power b equals to x, provided obviously a not equals to 0. Number 2, log a with base a m plus logarithm n with base a equals to logarithm a base mn. When base are same but the logarithm are different, that time they are multiplied. Okay. For example, log 2 with base 5 plus log 2 with base 10 gives us log 2 with base 5 into 10, that is logarithm to 50. Okay. Now third law. We can prove each and every formula, but later I am showing how this formula is coming. First of all, we write all the formula. M minus logarithm a with base n. This time it was in addition form, but here in subtraction form. So it will be logarithm a base m by n. Okay, m by n. See, it is very similar to the indices. In case of indices, when base are of same, that time components addition. But here logarithm addition means they are in multiplication form. In the same way, when they are in division form, that time logarithm are in when logarithm are in subtraction form, that time after converting they are in division form. Number 4, you can write logarithm a base a equals to 1. That means when base and logarithm both are same, then always value is 1. For example, logarithm 5 base 5 equals to 1. See, only a to the power 1, by this definition, a to the power 1 equals to a. So when base and logarithm are same, that time value is always 1. Okay. Now number 5, logarithm 1 always gives us 0. Whatever may be the base, any base. See, a to the power 0 equals to gives us 0. Any base to the power 0 equals to 1. We know that. So logarithm 1, need not to mention the base. Logarithm 1 is always 0. It may be, base may be a, base may be b, base may be c, anything base may be. Because anything to the power 0 equals to, you know already, 1. Now number 6. Logarithm a base b equals to, we can write logarithm a base c equals to logarithm b base c. Okay, this logarithm is divided into 2 logarithm. Okay, hence one new logarithm came, with that same base we multiplied. Next, logarithm a base b equals to 1 by logarithm. When we reciprocal the logarithm, base and logarithm interchange their position. Logarithm b base a equals to now 1 by logarithm a base b. And logarithm a base b equals to, we can also write log b by log a. And what will be their base? Base may be anything. Suppose both of the base is c. Okay. All these are the formula of logarithm. If you can memorize all this formula of logarithm, then very easily, like the indices, you can solve all the problems. Both the chapter, indices and logarithm, I think it's very easy chapter. And all the problems are also very easy if you can memorize and if you can understood what time we have to apply which formula. Okay, now I am going to prove one formula only or one law only of logarithm. See, everyone note down all the formula. See, in second formula I write logarithm a base m plus logarithm a base n equals to logarithm a base mn. I mentioned that when two logarithms are in addition from with same base, both the base are a, that time logarithm multiplied and they are converted into one single logarithm. Now how we can prove that? Say let this value is x, this portion is x, and the second value of second portion is y, and the value of third portion, suppose that is z. Now by the definition of logarithm, what we can write? A to the power x equal to m. Am I right? A to the power x equal to m. This is the by the definition of logarithm. Similarly, from here we can write a to the power y equals to m. Similarly, from here we can write by the definition of logarithm a to the power z equals to mn. Now see, value of m is a to the power x. So in place of m we can write a to the power x, and in place of n we can write a to the power y, as a to the power m equals to x and a to the power n equals to y. Very sorry. A to the power x equal to m and a to the power y equals to n. See, so we can write a to the power z equals to, base are same, so we can add the components. So we can write z equals to x plus y. Now what is z? Z is a to the power a base mn. And what is x? Log a to the power m. And what is our y? Log a base n. So hence proved. See, log a to the power a base m plus log a to the power a base n equals to log mn with base a. In this way we can prove all the formula. So next day we are going to start the solution of problems. So beforehand or before that, obviously memorize all the formula, try to explain all the formula, and obviously write all this formula at least 4 or 5 times in your copy. That time you can memorize all the formula very nicely. Thank you and have a nice day.